Hello, my name is Katie Makarowski, and I work for the Montana Department of Environmental Quality in our Water Quality Monitoring and Assessment Program. And I'm going to share with you today an overview of quality assurance and quality control, which is a necessary component of a successful water quality monitoring program. So it's useful to begin by thinking about why citizens or others might monitor water quality in the first place. So a common objective that I hear volunteer monitoring programs in particular wanting to achieve is education and community awareness. And so that's engaging community members in water quality, protection, and fostering stewardship. Others express that they're interested in characterizing water quality conditions, so describing current conditions, being able to make comparisons in water quality from place to place, and evaluating trends over time to determine if things are getting better or if conditions are getting worse. Others are interested in identifying water quality impairments, or really determining which waters are experiencing pollution problems. And then for waters that have been identified as experiencing pollution problems, source assessment comes into play to identify the cause of those problems. And this allows people to take the next step then to find solutions to those problems and identify ways that water quality can be improved. And when people are interested in improving water quality, it's important to establish reasonable restoration goals, and monitoring can come into play with that. And then as restoration or best management practices are implemented, monitoring can be done to evaluate whether those measures were effective or successful in improving water quality. But whatever the objective is that people express as their primary objectives, most programs would agree that they want to collect useful data that's high quality and robust, and that's going to allow them to achieve their goals and answer the questions that they're setting out to answer through monitoring. So first, to think about some of these definitions of quality assurance and quality control. Quality assurance is really the overall management of a sampling program, and this allows people to ensure that the data that they're collecting is of known and defendable quality. So examples of quality assurance activities include developing quality assurance project plans, or QAQCs, and sampling and analysis plans, or SAPs, implementing training programs as part of the project, and then also using established procedures that other people are using as well. Whereas quality control are more of the technical activities that are used to detect and control errors. So examples of quality control activities include collecting and analyzing field duplicates and field blanks, calibrating equipment, and reviewing data sheets to make sure they were accurately filled out. So various quality assurance and quality control activities are done at different steps along the way through a monitoring project. So some activities are done before field work occurs. So that's the planning and documentation kind of phase, and training people to make sure everybody's on the same page, maintaining and calibrating equipment to get it ready for use in the field, etc. Other steps are taken during field work, and that's helping to ensure that the people that are actually out collecting the data are following those documented plans and protocols, that they're documenting the activities that they're conducting and the data that they're collecting accurately on field forms, that they're collecting all the samples that they are setting out to collect on a given site visit, etc. And then other steps are done after field work is complete to ensure that data is being managed effectively in databases, that it's being evaluated and flagged if necessary, if issues are identified, and that your program is evaluating how things went on an annual basis, reflecting on lessons learned and amending plans as necessary. Now, a typical sample, environmental sample, goes through a lot of different steps before it becomes part of your water quality data set. And each step along the way has the possibility of error. And so natural variability is a common source of error. And unfortunately, a lot of natural variability is out of our control. So you can, though, reduce the effect of natural variability in your data set by developing good sampling designs and taking as many samples as possible at as many different representative locations as possible to ensure that your data set at the end of the day is representing the system that you're interested in representing. Handling error is another source of error that, when there's a human element of samples being collected in the field and mistakes can happen, handling error can be reduced by following established procedures for sample handling, for storing and shipping those samples, etc. And measurement error is also often a factor when any instruments are being used to collect data. And measurement error can be reduced by selecting appropriate instruments, by calibrating those instruments well, by maintaining them in good condition, etc., to make sure that the data that they're collecting over time is good quality and is comparable. There's a whole suite of data quality indicators that are commonly used to evaluate sources of variability and error while water quality sampling. And these evaluations can increase the confidence in the data by communicating to others how comparable, how complete, how representative, how accurate, how precise, and how sensitive the data is. So precision is the relative agreement among a set of replicate measurements. Precision is typically measured by field or laboratory duplicates. They're compared to one another to ensure that the protocols being followed are reproducible. So field duplicates are a common element of water quality sampling projects. Field duplicates are two samples that are collected as close as possible to the same place and time by the same person, and that are carried through all of the same steps of sample collection, preservation, storage, and analysis to ultimately produce two identical samples. And those samples are then submitted to the lab and analyzed, and the relative percent difference between those duplicates can be calculated and used to evaluate precision and make sure that proper sample collection and handling procedures were being followed. Field blanks are another common quality control sample that are collected during water quality monitoring projects. And field blanks are samples of deionized water that are prepared in the field, again using the same methods, containers, preservation methods, and storage as the routine samples are. So they're very similar to routine samples, except that they are produced with deionized water that is free of any analytes rather than using ambient stream water, for example. And field blanks are then submitted to the lab alongside all of the other field samples and analyzed to detect potential sources of contamination, for example, from sample bottles, sample handling, storage of samples in coolers, etc. So since this is analyte-free deionized water, you would expect that field blanks would return results of non-detects from the lab, and if any analyte is detected in a field blank, it can lead you to contemplate what might have caused that contamination and take measures to fix the problem. Accuracy is the relative agreement between an observed value and an expected reference value. And accuracy is typically measured in the laboratory by comparing the amount of analyte recovered versus the amount of analyte actually truly present in a reference standard, so the use of spiked samples and laboratory control samples. Representativeness is the extent to which measurements actually depict the true environmental condition or population. And so we typically achieve representativeness by developing robust sampling designs that minimize the effects of spatial and temporal variation. And so we collect sufficient number of samples at different times and places to try to capture all possible sources of natural variability. Completeness is a measure of the amount of data that you plan to collect compared to the amount of data you actually collected. And so samples inevitably can become broken or lost. And one way to counteract that risk is to just plan to collect more samples than you're actually going to need, just in case you're not able to collect all the samples that you thought you would. And then also to take care to use proper sample handling procedures and maintain chain of custody records so that you can track if samples are lost or damaged or broken, that you can track what happened to them. Comparability is the extent to which data from one study can be compared directly to either past data from the current project or data from another study. And the most common way to achieve comparability is to adhere to standardized sampling protocols and require that all participants attend trainings to learn those protocols well. And sensitivity is the limit of a measurement to reliably detect a characteristic of a sample. So basically, to ensure sensitivity, you can establish reporting limits from the laboratory that are low enough to detect an analyte in the sample that you're providing to the lab. And you can also make sure that you're selecting instruments that have adequate sensitivity to detect whatever analyte it is that you're trying to detect in the natural environment. Another thing to highlight with quality assurance and quality control measures is just the importance of good documentation. And metadata is one component of that. So metadata is data about data. So if you picture a result value that you get back from the lab, for example, this number 0.04. Well, this is just a number. It really doesn't mean anything unless it has all of its metadata accompanying the number itself. So the metadata would include all of the information like where was the sample collected? What parameter is it? Who collected the sample? When was it collected? When was it analyzed by the lab and what lab analyzed it? What medium is it from? Is it water or sediment or biological tissue of some sort? And what are the units? Is this 0.04 milligrams per liter or micrograms per liter, for example? And what method was used to collect that sample? What method was used to analyze the sample? What are the reporting limits? And are there any known errors or data flags associated with that value? And part of ensuring that there is good metadata to accompany your data is to make sure that participants in data collection are really taking time to completely and neatly fill out field forms and sample labels and chain of custody forms, for example, and just really stressing the importance of good documentation, clear handwriting, and taking the time before you depart from a sampling site to check over the field forms to make sure that nothing is missing or nothing is hard to read or nothing is inaccurate. So just again to reiterate why quality assurance and quality control is important, ultimately QAQC measures help people to collect good quality data and to share that data with other people. Documenting the QAQC measures that are used during a data collection effort, as well as the lab analysis components, allows you and others to then evaluate whether the data that was produced is going to be useful for achieving your monitoring objectives. So being able to determine when the data was collected, who collected that data and did they do it correctly, what methods were used in the field to collect samples, were the instruments that were used properly calibrated and maintained, what methods were used by the lab when analyzing the samples, and can this data be combined with or compared to other data that may or may not have been collected similarly, are important examples of why documenting QAQC measures are important. Also, QAQC helps to standardize activities and again helps ensure that data is comparable through time. So especially for programs that are implementing similar objectives year after year after year, but might have different people participating in those monitoring efforts, it's especially important to make sure that people are doing things similarly from year to year, so that at the end of the day, that data can all be combined together into one large, robust data set. QAQC measures really document the who, what, when, why, where, and how good elements of the data set that you result with at the end of the day. QAQC can help save time and money to make sure that you're getting the data that you want to get in the first place and not having to go back and redo anything because there were problems down the road. And good QAQC measures can also enhance the credibility of your monitoring program and really helps others recognize that you're doing everything that you can to ensure that you're producing good quality data that's going to be available for others to use for years to come. So that's all I have for today. Just a quick overview of quality assurance and quality control in water quality monitoring. I appreciate your time.